welcome to Tech Just Right. Today we are going to get into an exciting topic, which is key characteristics of a distributed system. Today we have Ravi with us.
Hello, everyone. This is Ravi, and I'm a software engineer at Amazon. Happy to be a part of this podcast. Let's talk about distributed systems. I am super excited to talk specifically about the AI ML stuff in the distributed system post discussing the main characteristics.
Today the key characteristics of a distributed system, right? So, whenever we say a distributed system, we usually talk about starting with a scalability perspective. So, let's get started with scalability. So, in scalability, any distributed system which needs to grow and manage the increased demand at any point of time. So, in that way, like scalability plays a major role in the distributed system. So, there are two kind of scalabilities there, like horizontal scalability and vertical scalability. So horizontal scalability is easy, easy to do in such a way like we can add more servers to the pool of resources. So vertical scalability, we can talk about like adding more power, let's say like a CPU or RAM or memory to an existing server. So at any point, it relies on the capacity of the server. So there is always an upper limit. In that way, like horizontal scalability is much better for our consideration than the vertical scalability. So if I want to give a quick example, let's say like we have a MongoDB or Cassandra, in the growing demand of data or more number of transactions are executing. In that way, like it can be easily scaled horizontally. Considering our traditional MySQL database, which is vertically scalable. So one thing, like it always there is an upper limit. What I said earlier is it like if you need to replace an existing server, it always have a downtime. So that in that way, like vertical scalability is underplaying than the horizontal scalability.
Before getting into the characteristics of distributed system and talking about the scalability, I would like to give a 20 years old, a 2 decades old introduction about a distributed system. It is nothing new. So this is nothing but interaction of independent components. Could be a DB, could be servers, could be any kind of systems, just totally independent. And they have some set of rules to pass the messages, to coordinate, and they communicate each other to solve the problem. So basically, this is what distributed system is. Going into the characteristics, all these scalability.
It was a very nice background, actually.
Yeah, all the scalability, availability, all the contents which you see on the screen implies on something called decentralization. Let's say that we are writing an application. So everything will be centralized. Like we'll have a server, we'll have a database, everything will be sitting in a machine. As Bali has talked about horizontal and vertical scaling, he has given an example of database. So decentralization means like splitting up the components into a way that it works in a good way, so that we can accommodate a lot of users and little bit of trade-offs. Now coming back to scalability, I have a counter opinion on the horizontal and vertical scaling. Specifically, the example: any database can be horizontally scaled and vertically scaled. So let's take a classic example. Let us say myself and Wali. Let's say that we are going to start a company. Let's say that company is going to do kind of it's a betting platform. Let's say this we are in India and this IPL is super famous here, and let's say that we create an application which does betting. So here, how do we spin up the application very fast? By a big system. Let's take an example of AWS. We are hosting an application in AWS. So AWS has its compute. Let's take it very simple. Let's not go into the complexities of the application. In a 9-way, we need a compute, which is kind of a server, and a database. So when you talk about compute, AWS offers different set of computes, like with the processor's capacity, RAM, and internal memory, storage, and whatnot. So which system should I purchase? Let's say before going into the application development part, I'll do some kind of a back of the envelope estimation. Let's say I'm in India. Let's say I just want to expose this betting platform for only CSK, which is a team, which is a cricket team, which is part of IPL League. So for them, the audience crowd is going to be in crores. We have seen in a lot of streaming platforms the number of audience watching a match or something. So I'm just giving a naive example. There could be some 5 crore, 6 crore concurrent parallel users. So considering that, how many connections I should be maintaining, so and how much of memory I should be having. So I'll go book 2 systems, which is like heavily big systems. Okay, so that is actually, I see this as a vertical scaling. So basically, I'm buying a big machines. I don't know how the things are going to be, so I simply go ahead and buy the big machines. Then down the line, after 2 or 3 matches, I see that uh, I kind of over purchased the compute and the scalability aspects. Let's say I over purchased them. So what I do is I kind of opt out for the simpler machines. I buy some smaller machines. So how do I find out? We ideally find out using metrics. So we develop our application, deploy in the huge system. We buy big machines and just run it for a week, and we see the space utilization and CPU utilization. That's very less than, okay, it seems this for this use case, this machine is not going to be useful. Of course, we can theoretically match and get the most optimal machine, but it depends upon the crowd, the customers. This thing varies. It is totally unpredictable. So we always buy a big machine so that none of the customer gets disappointed. That's how we start with a big scale, which is vertically scaled system, and we reduce the vertically scaled systems to a smaller chunks. It's like a smaller instance of AWS. Rather purchasing $1,000 3 machines, just $3,000, I'll buy maybe like 10 machines with a smaller compute so that I can parallelly process and serve multiple users. Today, coming to the usage of generative AI and all these things are like gonna work in a beautiful way. I've seen this specific use case. In order to record the metric, that is done by engineers. We all do it. When we code, we record the operational metrics, business metrics, and whatnot. The problem comes when leaders wants to see this metrics. Okay, CloudWatch is one of the examples that, as I already said, we are using AWS. I think CloudWatch is kind of a kind of service which records the metrics for every user action. But if you want to communicate this as a graph, like how the system performs, there we can use LLMs. You need not go and bug an engineer because people work all across the globe. You can use LLMs to effectively understand the meaning of the metrics and what does the graph says. That's kind of a very high level overview of scalability.
Yeah, it was nice and it was relatable with a very good IPL kind of season, right? So it is more enjoyable and relatable. Yeah, that was great. And yeah, let's move on to the next interesting stuff, which is the reliability. So this is another main characteristics of a distributed system. So if you talk about reliability, so it is nothing but the ability to operate even with failures and faults or errors, whatever we call, like in those cases, how it is maintaining end-to-end correctness. So how it is reliable. That's how it is meeting the user expectation. That's the primary thing which we need to have it as part of a distributed system. And if I give it an use case, so let's consider a e-commerce platform like Amazon. So if it is, we are adding multiple products to our cart, right? So if we are handling the order transactions, so if a machine which is handling the transaction, if it goes down, so it should not affect the end user. So another healthcare machine immediately needs to pick up and it needs to solve the order transaction. So at any point, it is a mission critical application and it should not lose any user's single order. So in that way, how it is achievable? So it is achievable replication, how we can do the data replication, how we can do the software application replication or resources replication. It can be achievable through that. So, but it always involves a cost. So definitely there is a cost which is involved. So you need to invest on that. So in the perspective of resilience, how you handle this situation. So we need to invest cost on that. So that's another real-world use case which I can immediately give it as part of reliability.
Yeah, that's a very good example. I want to add a couple of points more because you've talked about that. So I see the problem when we talk about reliable. Reliable comes in multiple aspects. So the distributed system itself has multiple components involved. As we talked in the previous example, one is compute. Maybe in a simpler terms, people use a terminology called node. So we'll also use the same. So And also we talked about the decentralization part, the communication part. There can be a latency involved. I see these are the major problems of distributed system. So one is like the communication between the nodes might create a delays, and it's not always that. Even a lot of people face during COVID that working from home because of network challenges. And think about a real-time systems, let's say banking system or maybe a stock market trading system. It's going to be a nightmare. So how the things will be reliable? But think about it in a distributed system. Let's say it involves a lot of transaction. Let's say stockbroker platform. How it's going to be reliable? That's a huge nightmare. that's something, the latency part. If you ask me what we can do to solve it, the simpler and straightforward thing, it depends upon, answer I could give is, it depends upon your problem. What is the problem and where the latency? Network partitioning. Sometime, as you said, that the nodes might go down. We don't know. Given the single distributed system has an advantage that we use multiple nodes to handle. Let's say if a server in a place, region one goes down, we route the request to a different place. But still, let's say if that node one goes down in after me entering a first level of set of information. Let's say I have some kind of a form to be filled by the user. After entering all 3 forms out of 5 forms, the server goes down. So now the problem is to the engineers. Like, should I ask the customer to re-enter the data, or some way I can able to figure out the data or cache the data and do the things? That is the second problem. There are a lot of things to identify whether the node goes down or not. There are a lot of strategies. Let's say usually the distributed systems we use is something called heartbeats. The system each other pings for the availability and checks if it is up or down. And if something is lost, if some data is lost, or if some node is lost, node itself went down, then who handles the, let's say I updated my username, but the node went down. Who takes the responsibility that the right data is written into the database? There are a lot of algorithms for maintaining. So basically they have the node has an agreement, right? They have some kind of an agreement protocols, consensus algorithms like Paxos and all.
Available resources, how much maximum benefits we can obtain. That exactly makes the distributed system specially. Right?
Exactly. Yeah, you talked about replication, right? That's a wonderful topic. How to validate the consistency of both the databases. Again, that's not mandatory that you should maintain consistency always. Maybe in future videos you can talk about something, a famous thing called CAP theorem. That's all really I could think of the reliable things.
Yeah, right. Yes. Next, we can go on to the availability. So it's the ability of the system to remain operational, right? So it needs to serve the request in the specified amount of time. So that's we always have an service level agreements for availability. So our system needs to provide or perform the operation in the specified amount of time. So that's the availability. And what could be the difference of when we talked about reliability and availability? So in availability, the system needs to respond to the request, but it not always needs to be correct response. It can be it not necessarily to be consistent response it needs to give. It can be it needs to give a response. That's all it can do. That's what we agreed upon availability.
So, I would like to add a quote on this. I somewhere read that it is good to be incorrect and alive rather correct and dead. So it's good to be alive and incorrect, so that there will be, and we can use some kind of techniques to make it correct. But there is no point in being correct and just going out of the network.
Like the reliability systems. Let's say like if it is addressing all the real-time scenarios, all the issues, if it is resolving, the reliability system can mature at some point as an availability system. But the vice versa is not true actually. So the available system not always be a reliable system. That's something which I wanted to tell. So next we can talk about the efficiency. So in distributed system, how we are saying our system, how we are measuring our system, is it efficient or not? So there are 2 standard measures which we can say. Like one is the response time, which is nothing but the latency, and the next one is throughput, which is nothing but the bandwidth. So if we say response time, so let's consider a thing. We are running a task in a distributed manner. So and it is giving list of items as the response. So considering this, how long it is taking to deliver your first item. That is
Mhm.
your response time, nothing but the latency, and how many items it is returning, the volume that we can call it as a throughput. But throughput is always measured in a time unit. So we can say in seconds or milliseconds, so whatever the time unit which you are considering. So you can say like how many volume of items it is returning or transactions it is running. We can say that is the throughput.
Yeah, I just have one point. So basically, uh, about availability and efficiency, right? Like whenever we are selling a product, I see this as in a real time that, let's say, I'm exposing a service to customers. Let's say I'm exposing a database or something. So how do I expose it? So is there any measurement for this availability and efficiency? Yes, there is. People call it as nines. Like I have like 3 nines of availability. This 99.9%, 5 nines of availability, 9 nines of availability. So that's how the availability is. Like, that much percentage things would be available. About the efficiency, right? What is the primary the purpose of service level agreement? Is that something like it is kind of a contract or an external agreement I'll show to my customers. SLO, which is service level objective, is something that internal to the system.
That's good. So yeah, next to one thing which we need to touch upon is the maintainability. How easy it is to maintain, and how easy it is to repair or recover from failure. So that's one of the important consideration when we are doing
Yeah.
a distributed system. And so let's say like how fast are we catching our failures? So that's where like we can recover fast. So let's say like your repair time might affect your SLA, right? So
Yeah.
your repair time, if it is increasing, so then you will be always having a downtime. Then that is affecting your SLA. So that's the foremost consideration. So how early you are detecting and how early you are addressing that failure and making your
Mhm.
system performing better to achieve your SLA. So that's additional and important consideration which we need to take as part of our design.
For on the aspect of maintainability, I have a wonderful experience deploying an application. So what happened is there was a product which does not have a cloud side configurability, and the product was deployed to the customers. It was super challenging. The only way to revert the changes, because there are always an edge case, there is always an unpredictable scenarios which might happen. It's always good to have a knob in after the product is released. So I see maintainability as something uh, goes with configurability. I would say an application goes back. You can write a super good application. It's highly maintainable. Like you followed all the design principle, architectural rules, but so anything can go wrong in the field. So it is good to have a cloud control that after we release an application, we can able to do an update. Let's say the feature is not working right in a specific region. So it's always good to have some configurability through cloud. And I'm just comparing maintainability with a scale now. Let's say my customer is spread across the globe. Let me take NASDAQ as an example. I'm creating a stockbroker application for NASDAQ. And a lot of people will use my application. I know this is mostly US users will be using it, but there can be some foreign investors too. So now, how I'm going to deploy a feature? Let's say I'm deploying a feature in that application. It's going to be AI-based analytics. AI understands the candlesticks and gives some textual information to the new customer, something like this kind of a feature. And let's say that, so how I'm going to spread this feature? Like, am I going to give update to all the customers in single shot, or how should we do it? We should do it in a probabilistic way. Like we should give an update for some percent of customers. Let's say 10% of customers. After some time, we are getting a good level of metrics, we should be expanding it to next 20% of customers. Progressively, we should increase our customer base to see this feature. So mostly it is based on region. So on a day one, I can release it to US customers because US customers will be the maximum number of people uses my broker application as it is based on NASDAQ. Then I can expand it to Europe and then maybe India or something like Asian countries down the line. So so that's how things goes hand in hand with scalability and maintainability.
That was amazing, and it is giving a very big picture how we can handle that area.
Yeah.
That was really nice, and I think we covered now the key characteristics of distributed system, and we have talked about touched upon lots of areas which
It
can be
is,
easily relatable.
yeah, it is now time for you folks to add on some points if anything can be done better with AI.
Yeah, good. And we should catch up with another interesting episode. Thank you very much, folks. Thanks. Bye.